All right, so let's look at this graph. We started looking at this one. So who remembers this is a quadratic. So yesterday we had linear functions. Today we're talking about quadratic functions. So who remembers from a quadratic, what does A do to your parabola? Yep, it does stretch and compress. But what else does it do? It does something else. It makes it upside down. When A is what? When A is negative, it makes it upside down. And when A is positive, it makes it up. Yeah, so when A is positive, so we're going to talk about A and C. When A is positive, your parabola is a smile. So one thing, it says, what can you tell about A and C from the graph? So what I know about this graph, even though I don't have the equation, looking at the graph, I know that A is positive. So A has to be positive because this one is a smile. So we know that for number 3, A is positive. And then what do we know about A for number 4? Because this one is a frown. What does that mean about A? A is negative. Good job. Okay. Now, when we're talking about a quadratic, the C value is your y-intercept. So this is your y-intercept. So C for number 3, this is where your C is located. And for number 4, this is where C is located. So go ahead and tell me what you know about your C value for 3 and 4. Take about 60 seconds and write down what you can tell about C from looking at the graph. So what do you know about C for number 3? Yeah, we could tell that C is definitely negative. So we don't really know what the C value is, but we know C is negative because it's below the x-axis. And what about number 4? What do we know about C? It's positive. Good job. All right, so we only have one example to finish, and then we'll have the rest of the class to finish our corrections, and you can make your appointment for your test. If you want to do a retake, you can make an appointment for your retake. So in your review book, go to page 218, and we're going to look at example 6. Okay, so we have 2 different graphs for question number 6. The first graph is f of x. So f of x, this is the f of x. I'm going to write it a little bit bigger because they wrote f of x, but it's kind of small. But this is the f of x graph. So this is the equation that goes along with this graph. And then we have g of x, which they did not give us an equation for, but they did give us the graph of g of x. So the first thing we need to do is finish filling in our table. And since they graphed it for us, we can actually look at our graphs to find the value of y. So looking at this graph of f of x, what is the y value when x is negative 2? So here is negative 2. So take a minute. Don't say it out loud. But fill in the missing y values. Looking at the graph, tell me the y value at negative 2, the y value at 0, and the y value at positive 2. So, and because they graphed it, we can look at the graph to find those points. Now, they did give us an equation, so you can verify your answer by substituting your x values into your function rule. So if you're not quite sure, this is your function. It says x cubed. You could also type in the negative 2 to verify. But I will tell you that these are all whole numbers. So take a minute and fill in your missing y values. All right, so looking at your graph, what did you get for negative 2? What's the y value when x is negative 2? So here is negative 2 on the x-axis. So what is the y value at this point? 6, okay. Oops. All right, 0, which is right here. What's the y value when x is 0? 0. And what's the y value here when x is 2? 10. All right, so now let's look at part B. Part B says analyze the extrema. Which function has the greater relative maximum? Now going back to chapter 1, if you don't remember what a relative maximum is a hilltop. So it's kind of like a hilltop when you're looking at a graph. So for part B, where it's asking us to compare these two graphs, so we have the f of x and the g of x. So this is f of x. This is g of x. Notice that because this is an even degree, the arrows are both going up on both sides. It's an even degree. All right, it doesn't have a maximum because it goes up, but right here, this would be called a relative maximum. Let's go ahead and put a point right there. So that's your relative maximum for g of x. For f of x, the relative maximum is right here. So it says f of x has a relative maximum at approximately y equals 6. So right here, in this graph, notice that the y value is 6. But what's my y value for my relative maximum on this function? It's a number between 2 and 3. So which one has a higher or a greater maximum? F of x or g of x? F of x. So let's go ahead and fill that in. All right, now let's go ahead and compare the zeros, the y-intercepts, and the end behavior. So it says the zeros, x and y-intercepts, and end behavior. All right, so let's start off with the 0. What's another word for 0? Who remembers from yesterday? Root, solution, x-intercepts. So when we're looking at a graph, our zeros are our x-intercepts. So what I want you to do is take a minute, starting with f of x, which is this function here. Tell me first of all, show me with your fingers how many zeros we have for this graph. How many zeros do you see? You see 3? All right, good. Go ahead and write down the 3 places for f of x. So take a minute. There's 3 places. So write down where I put those 3 green dots. So our first one is here. Our first 0 is at -3. What about our next one? Where is this one at? 0. And the last one is 1. All right, now let's look at g of x. Show me with your fingers how many zeros do we have for g of x. All right, go ahead and list those out. So we got 1, 2, 3, and 4. So our first one is at -1. Now this one here is in between -1 and 0. So it's halfway in between. So what is that point going to be? Negative what? -0.5 or -1/2. Here, what does x equal right here? 1. And our last one is 2. Now, x-intercept is the exact same thing as 0. So when we list our x-intercepts, it's the exact same. So our x-intercept is going to be for f of x, we have one at -3, 0, and 1. So it's our same answer. For g of x, our x-intercepts are at -1, -0.5, +1, and +2. Your y-intercept, they already filled in for you. But you have a y-intercept. For g of x, your y-intercept is here, which is 2. And for f of x, your y-intercept is here, which is also 0. All right, the last thing we're going to talk about is our end behavior. So looking at f of x, so f of x is this graph here. What is this graph doing on the left? So this first arrow is the left arrow, and then this means the right arrow. So what is the arrow doing on the left side of f of x? Is it going up or down? Down. So what are you going to write right here? -infinity. Good job. And then on the right side, it's going up. So that would be +infinity. What kind of function is this? Is this even or odd? What would you say for this one? Even or odd? For f of x? Odd. Yep. How do you know it's odd, Chris? I agree. They're going different directions. Exactly. One side is going down and the other side is going up. Now, what about g of x? What kind of function would you say this is? Even or odd? Even, yeah. Because both arrows are going in the same direction. So what are the arrows doing on the left side and the right side? Are they going up or down? So for g of x, you're going to put a +infinity for both. Okay, so I'm going to make a quick change to homework. I'm taking off one of the questions. Homework 22, you should be able to turn it in today because we have finished the majority of it. Take off question 35. We're going to take that one off. So for the rest of this class period, you can work on homework 22. You can get tutoring. You can also work on your test corrections.